Docker and running a containerized application in a Docker engine platform. So let us first discuss what is Docker. So Docker is basically an independent open source tool for the developer or system admin to develop, run, distribute a software package in a loosely coupled architecture. What is loosely coupled architecture? If I can distribute an applications and its associated dependencies, APIs, everything with that particular applications, that means the application doesn't depend on any other dependencies. So it is very easier for that applications to migrate from one system to another systems, which is not dependent on the intrinsic hardware platform. So this type of loosely coupled services are sometimes called microservices, which are also being used in a Dockerized platform. Sometimes Dockers are basically termed as the OS virtualization also. Let us discuss about the traditional software development platform. If you can see over here in this picture, now the earlier 2000, how we used to develop a software. The softwares are being developed on top of a big server, and these are the associated applications, APIs, dependencies are installed on top of the server, so that we can install we can develop a particular apps. Now the apps is now being developed, and now we have to install or migrate it to client system. Now the client system software configuration and hardware configuration may not be same, so we have to build the same type of software and hardware configuration in the client system also. But the worst part is, it will one thing is that it will delay the software deployment, as well as also increase the cost also. Sometimes we have to deploy somebody in the client side, and the worst part is, if I need to update the software, that case I have to check that whether the dependencies are also working with that update or not. Basically we have to check the background compatibility. If the background is not compatible, that case the updated version of the software will not work. Nowadays, to get out of this problem, what we have introduced, that is the virtualization concept. What is virtualization? Virtualization is basically we have an infrastructure, hardware infrastructure. On top of the hardware infrastructure, we are installing the hypervisor, that means the virtualization manager, machine manager. So like a VMware is one hypervisor, or VirtualBox introduced by Oracle is another hypervisor. Microsoft has its own hypervisor, that is called Hyper-V. So on top of that hypervisor, we are installing different software, different operating systems. This is one of the operating systems, guest OS, and the necessary bins, libraries, etc. are installed to run that application A. This is another hypervisor where another guest OS is there. This is another hypervisor. Now on top of that guest OS, we can install not only one application, so we can install multiple numbers of applications. Now if we want to migrate, or if we want to make it portable from one system to another system, so what we have to do, that we have to copy that virtual machine and put it in another system. Now that case also, one thing is that the disadvantages are that those virtual machines are also resource intrinsic. That means if I want to install multiple number of virtual machine, I need that hardware must be equipped so that the multiple number of virtual machine can run simultaneously. So the resources are required are more. And another thing is that the migration is always not guaranteed. Why it is so? Because if I install a virtual machine on top of a particular hypervisor version, if I want to migrate it, that case it will only run on that particular version of the hypervisor. So it is hypervisor dependent. To get out of this problem, what we do, that we have introduced the open virtualization format concept, where it's a universal format, so which will be recognized by any hypervisor. So to migrate a virtual machine with its intrinsic applications, what we do basically, we convert it to a open virtualization format and then migrate it. So that solve the problem, but solve the problems in a certain extent, but the problem remains the same. That means you need more and more hardware and software resources, but these problems can be overcome by the Docker concept. In the Docker concept, what we do, that we don't require any hypervisor. What we basically do, uh, we are installing one host operating system. On top of that, we are installing the Docker, and uh, on top of the Docker, we are running the different types of applications in a containerized manner. That means each of the application is one container. So here the only the applications will not be there. Its required kernel will also be there. So what are the things will be there? Necessary APIs will be there, dependencies will be there, and the kernels that are required, that is also will be there, and in a lighter manner. So the container will contain one lighter version of that entire applications. And as a gist, if I want to move that container from one machines to another machine, so it will move along with its dependencies, APIs and everything. So it is very easier to move from one Docker platform to another Docker platform. Now in that case, I can install this container with the Docker engine. So I need this Docker engine as well as the container also. So if I want to move this one container, so I can just move only this container only. We don't have to think about that which Docker platform it was there. I can move easily. Now another best way is that earlier we have seen that virtual machine is also providing an opportunity to create one migration platform which is used by the container. Now if we can introduce the container on top of a virtual machine, that is the best option. So here you can see that I have an infrastructure. On top of that infrastructure, I have the hypervisor, and on top of the hypervisor I have different types of guest OSs. So this guest OS have one Docker platform. It has different types of applications. Two applications are there, and this is one container, and this one is another container. And if I consider this guest OS, which on top of that guest OS I have another Docker platform, and on top of that I have one application. So within my hypervisor I have different operating systems, and each of the operating systems having one or more applications are running on it. And if you don't require a Docker platform, that is also okay. So this is running, and you can create your applications over there. So you can have the applications with only virtualized platform, so which is shown over here, and you can have the applications with the Docker container platform, which is on top of an hypervisor platform. So this is basically an hybrid architectures which will give you more flexibility and robustness. Now today we'll show you how to create a Docker platform on top of an operating systems, that is in a virtualized platform. Not only in a virtualized platform, it is in cloud-based virtualized platform. That means in AWS EC2 instance, we'll create one operating systems within 5 minutes. It will just take 5 minutes only. And after that, on top of that EC2 instance, we'll install Docker, and we'll show you how it is working. So let us see, and you will be excited to see that this type of applications can also be built. So we'll basically, what will you do that in my AWS EC2 dashboard, I have three operating systems are there, three virtual machines are there. These are called the EC2 instances, and these are right now in I have stopped it to stop the billing also. Now from the beginning I will show you how to launch an instance. I will take one Amazon Linux instances over here. Already in my earlier videos I have shown how to create one instance. So but if somebody wants to see it from the beginning, that is why I am showing it from the beginning itself, but in a shorter manner. I am not going to tell you the details, what are the hardware platforms I am taking, Basically what will you do that, we will take we have to choose one template, and we'll take the minimum template over here, as well as we'll choose that, and also the how much hard disk space is required, that will choose, and what type of virtual private cloud platform we need to take. And the important part is the interfaces, that means how the inbound traffic and outbound traffic will go. So that is most important, otherwise your virtual machine will be created but it will not run properly. So I'm using AWS Educate because we have an educational platform that is provided by AWS, and thanks to Amazon Web Services for that, to providing us the services through which each of our students are getting $100 credit voucher per semester to complete all their labs. So in that process, you don't have to provide any credit card details, as I have also been provided with $100 credit voucher. So with that $100 credit voucher, I am using that one. I have just now $60 remaining out of this. And if you click on the AWS console, then it will go directly to the AWS console without any, your credit card details required. So right now my running instances are 0. I'm launching one instances. Now I'm taking Amazon Linux. Now these are the different types of templates. Each of the template details are written. There is a huge um, manual is there. You can visit that manual, or if you click in any one of the systems, you can get the details over here. T2.large, this is a template name. The variable ECUs to virtual CPU, 2.3 gigahertz of processors in each CPU, Intel Broadwell, and 8 GB memory, and elastic block storage are being used. Now EBS, how much is required to be chosen, that is up to you only. So as an AWS Educate user, I don't have the permission to use all type of application operating virtual machine to choose. So I can use that this one general purpose, that is T2.2x large, which means that 8 virtual CPU I can choose with 2.3 gigahertz and Intel Broadwell and 32 GB of memory. So let us see. And sometimes it is also noticed that if your credit balance is low, that case they will not also allow you to choose highly resource intensive virtual machine. So these are the default values. I'm not going into details of all those default values. So 10 GB, 8 GB is given over here, 30 up to 30 GB it is free. So let us take 20 GB of general purpose SSD volume. Now in this security group, it is taken as the for the SSH. Will as it is a Linux platform, it is better to open your instances interfaces through SSH only. But we need to choose the anywhere where the inbound traffic and the outbound traffic is open, so that anybody can access any user can access this traffic. So whenever you will choose this anywhere rule, that case immediately you will get one warning that you are opening your firewall. We recommend that security group rules to allow access from known IP addresses only. So two warnings are coming. One is that this instances is not under free tier usage. Obviously, we have not chosen the free tier usage, as well as this instances security group security policy is very low. Now we have to choose a key pair. So I will show you, as I told that I will show you it from the beginning. So I am creating a new key pair. So let us see that how many key pair I have created. I have to take one unique name. So third, fourth, second. So okay, we can take one fifth instances, or fourth instance is also fine. Download the key pair. Now launch the instances. Now this key pair is generated in .pm format, which is suitable for SSH only. But as we are using, we will use putty. So putty can recognize only PPK format. So it's in public key format. We have to convert that public key to private key using putty gen. Now let us search for that fourth instances where it is being downloaded. Okay, so I have to check all files. Now this fourth instances is there. Open that one, save private key. Let us stored in document fourth instances. Okay, now let us find out the access API. And open putty. The host path. And another thing we need to do that sometimes we face that if it remains inactive, that case immediately the connection get lost. So give a refresh limit and put the authentication private key, that is fourth instances over here. Now this is your AWS Amazon Linux based instances. So instances creation is complete. Now we have to update the instances. Okay, now my update is complete. Now install the Docker. Sudo Amazon Linux extras So now my Docker engine is installed. So already I have discussed that whatever applications I have to build, that has to be built on top of a Docker engine. Now, if your Docker engine is stopped, that case none of the container will run. But even if your Docker engine starts, that case also, until and unless you don't run your container, that your container will not run. So to run an applications, you need to run, open your Docker and as well as your container. Now to run your Docker services, write sudo service docker start. So Docker engine is started. Now we need to check that whether there is any container is there or not. Obviously there will not be any container. So if for that, to check that whether any container is there or not, sudo docker ps. So you can find out that the container ID, image, command created, status, ports, names, all are there, but there is no container present over there. Now to check that the whether which Docker version it is. So it is showing that 18.09.09 and C means community edition. So community edition is an open source one, but another is an enterprise edition EE, that is proprietary, and you need the subscription for that. Now let us check that whether there is any Docker images are present or not. So we have not pulled any Docker images also. So in the repository also it is showing that there is no Docker images present. Now you can already I have mentioned that there are more than 22 million Docker images are there in the Docker image repository. So you can, if you go to Docker repository platform, that name is Docker Hub. So if you go to Docker Hub, you will get millions of Docker repositories are there. You just have to search which Docker repository you require. Suppose if I want WordPress, suppose WordPress, so immediately its Docker images will come, and it will also mention that what command you have to give in the Docker to pull that WordPress. So as this is sometimes called the Docker registry also. Docker registry's main work is to distribute all the Docker repositories. So you have to pull it from the Docker repositories. Even you if you create if you have created any applications, you can push it into your Docker repositories through your account and also through the GitHub. Now suppose if I want to pull Ubuntu, new Ubuntu version, so Docker pull Ubuntu 14.04, or suppose the new edition, that is 18.04. So it is showing that I got permission denied while trying to connect the Docker demo. Okay, so I don't have the necessary permission. So let us download an older version. Okay, I have not given the sudo, that's why. So I can download the current version also. Sudo docker pull ubuntu. So new docker ubuntu 18.04 is installed. Now let us check this one, sudo docker images. Now you can see that I have one Docker images, and see here that this Docker image repository size is only 64.2 MB. Now the earlier I got an error to install this one because I don't have the super user password, super user authentication. That is why it is restricting me. So to get out of this, you can go to user mode also, and directly without using sudo also you can do this. So what you have to do, sudo user mode, and my username is EC2 user, which is the default username of Amazon Linux. Now I think I don't require any sudo. No, it is not working. So this is the Docker info. Now sometimes you can pull any small programs also from the repository file. Suppose if I specify sudo docker run, Oscar Hane is one of the developer, and for that he has written one small input program, that is hello echo. Whatever echo he will give, so it will run that one. So it is first downloading that Oscar Hane Hello Eco program, and now it is showing the result also. I am running the first container application. Whatever you are writing, it will come as an echo. And this one also is not a container, it is a Docker repository only. How do I know this one? To see sudo docker images. So here it will show you that you have two repositories. One is the Ubuntu, another is the Oscar and Hello. Now let us check that is there any container is also present or not. Look at, there is no container is present. Now to put one, suppose I'm putting one container over here. So how to do it? Suppose I want to put one run one WordPress container on top of that Docker Ubuntu Docker platform. So for that, what I have to do, sudo docker run main, and the WordPress container name is some WordPress. Now I have to link that WordPress with some MySQL. Okay, first I need the MySQL first, then I can go for that WordPress. Okay, so that case what should I do? That first run that MySQL platform first. I have to put the MySQL password also. and password is my secret password. Now check sudo docker ps. So you can find out that one container is not running. Now you can stop that container also, or you can remove that container also. Now on top of this, if I want to run that container again, you'll find out the same command I am giving to run that container again. So it will give you that command that it is already is in use. Now you can do two things. Either you can rename that container and run install that container as application on top of the docker, or you can delete that container. Now before deleting that container, you have to stop that container first. So to stop that container, what you have to do? Sudo docker stop. What is the container name? Container name, I think some MySQL, na? Now some MySQL is stopped. Now you can delete that container. Sudo rm sudo docker rm, now name some MySQL. Now if you check sudo docker ps, you will not find any container over here. That container is now deleted. Now if you can install that container again. Now you can install that container again, and if you check, that container is there already. So I think the basic commands and how to create a Docker platform, and on top of that, how to create a container, that also you have understood. The next class I will show you how to create one uh, platform based application, PaaS applications on top of a Docker. Thank you.